Hi, everybody. We appreciate you spending some time with us today. As we get started, you should see two poll questions on your screen. We'd love to find out if your organization has changed how it's prioritizing cloud misconfiguration risk over the past few months and how you're going about managing it. What we've seen is hackers graduating beyond simple cloud misconfiguration exploits to more advanced attacks that leverage multiple misconfigurations in order to find and breach data. And that's the exact kind of scenario that Josh is going to walk us through today. While Josh is going to be focusing on AWS, these same concepts and kinds of misconfiguration vulnerabilities apply to other clouds like Microsoft, Azure, and Google's cloud platform. I'll be back after Josh's demo to facilitate your questions. And with that, now I'll throw it over to Josh.
Thank you, Sivia and Drew, and welcome everyone. And I'll echo Drew's thanks for your attendance. Let's talk a little bit about what we're going to go through today. So, agenda at a high level, we're going to do an overview of cloud misconfiguration risk. It'll be a few slides. Then we're going to go into a live demo of that cloud misconfiguration exploits in action. I'm going to be jumping between three different applications when I'm doing that: the AWS console, the Fugue console, which will show us some nice things about the environment, and a terminal window. And when I'm in the terminal window, which is the black screen with the green type, I'm pretending to be a bad guy. In the other two, I'm really pretending to be one of the good guys. So then we'll go over some actionable steps to secure your cloud environment. I'm going to kind of sprinkle those through the presentation as well, but we'll try to summarize them at the end, and then we'll have a few minutes for Q&A. So what is cloud misconfiguration? It is getting your cloud resources configured in an insecure way, and it's a major security risk. This in the next slide, we've got some percentages, in this case 93% concern for major security breach due to misconfiguration. This is from a survey Fugue did last year of 300 users of cloud who are operating at large scales, and 93% were concerned for a major security breach, and that's backed up by this quote from MacDonald at Gartner that nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes, and that's been in the news quite a bit recently. So interestingly, I think if you read the DOJ filings we have on the recent breaches, or recent Capital One breach in particular, this bears out. But this is what our survey respondents said to us they were most concerned with. 66% said they were worried about IAM, about identity and access management configurations. Over half security group or firewall rules, and also over half object storage access policies. And that's really the three I'm going to focus on today for this scenario. Also, a lot of folks said encryption in transit, but we're going to look at those first three. So cloud misconfiguration is often overlooked in the real world. There are a number of reasons for this. One is I've seen in many events I've spoken at, conversations I've had, people just haven't been aware how important this is and how much exposure there is and how much risk there is. And specifically kind of traditional security organizations who think more in terms of perimeter defenses and endpoint protections don't yet often have their heads around the developers configuring infrastructure, well-meaning, by the way, developers and talented developers often, that miss these misconfigurations. And on the developer side, a lot of times there isn't good enough tooling. So a lot of times these get overlooked. But in addition to that, many dangerous cloud misconfigurations aren't really recognized as misconfigurations by security teams. They're not considered policy violations by the compliance frameworks that many of us use and rely upon, NIST or CIS or whatever. They haven't really captured the full realm of how misconfigurations can be exploited by black hats. And that, therefore, misconfigurations of one form or another are very common. In fact, I would say in my experience, and prior to founding Fugue with Drew, I was at AWS. I've never seen an AWS environment that didn't have some misconfigurations. They're very common. So a little bit on hacker strategy. Kind of in the old days, and by the way, this still happens, where bad guys will target an organization and then search for vulnerabilities to exploit. But more often than not, what we're seeing these days are sophisticated either single actors or organizations that are just looking for vulnerabilities anywhere they can find them, cataloging those, and then prioritizing the target organizations. So put another way, if you have one of these misconfigurations that's public facing, the bad actors are using automation to go find that. And then they're attempting to exploit it. So you don't have to have a big name to be discovered. There is no security by obscurity when bad guys are scanning every IP address on the public internet multiple times a day, which is now happening. So I promised we'd only have a few slides. That was a few slides. I'm now going to jump into some demonstration. And to get that kicked off, I want to begin with describing what we're actually going to be looking at in terms of cloud infrastructure and what the bad guy is trying to exploit, and a little history on the scenario I'm describing. There are many, many, many kinds of cloud misconfigurations and exploits of them, so I can't do in an hour a kind of general explanation of all of them. So I'm going to walk through one particular scenario. And this scenario is, I got, as an on-call engineer, got a message at 1 a.m. that the application is down and I need to go in and fix it. And so what I did in order to accomplish that, and I'm remote at the time, I spun up a separate little VPC. I created a maintenance host, which is a bastion host, a jump host, and I did my maintenance. And then at 4 a.m., when I got the app up and running, I forgot to turn those things off. This is actually a fairly common scenario in my experience. So let's talk a little bit about what I configured, and let's jump over to the AWS console to see exactly what I built there. So I opened briefly a security group. You can see it here as this maintenance security group. Oh, let me turn on my cursor highlighter so you can see where I'm pointing. This maintenance security group. And since I'm only planning on being in there for a few minutes and then deleting things, I actually opened up SSH. And then in addition, for my EC2 instance, I created just a little jump host, and I gave it an IAM role. And I think it's really important to point out, in this case, it's called maintenance role. You can see it right here. When you're creating an IAM role and you're deciding on what access privileges it needs, this is definitely an area that you need to be very concerned with least permissions for the purpose, but that can be hard to do. And so we often see issues around people doing that. And let me just point out kind of why here. So if we go into this maintenance role, so it's 1 a.m., I'm trying to get things fixed. I'm going to create a policy, and those policies are pretty liberal in this case. Well, why would I make such a liberal policy? Let's edit this policy and look at my choices in terms of what I need to accomplish in order what I need to have open in order to accomplish my task. So I'm just going to go into the EC2 settings for IAM, and I'm going to start looking at all the permissions that are available. This is a sizable list. So to have least permissions, I need to know exactly which of these, including their dependencies and cross-service dependencies, as to which of these permissions I need to do my job. So it's a common scenario in my experience for somebody to go in and try to do the right thing, try to be least permissive, but run into error after error in terms of what they actually need to do to accomplish their task, and therefore open things pretty wide. So what we've got here is an unfortunate kind of confluence of events. We've got this EC2 jump host that we forgot to turn off. We've got a security group that's pretty wide open. And we've got this EC2 instance running as an IAM role that is overly permissive. So when we're talking about IAM, it's important to understand this is not just like user permissions to access systems. In the cloud world, whether it's AWS or others, identity is used for the components of cloud to talk to other components of cloud. So what we're talking about here is this EC2 instance actually has an identity that grant it permissions. So that's my imaginary scenario. And in my imaginary scenario, when I went to bed at 4 a.m. and I woke up the next morning, I forgot about this stuff. This is also pretty common to have orphaned infrastructure out in the environment. So to press ahead, I'm now going to actually let me retrace my steps a second and redescribe this. So we now have some orphaned infrastructure. We have an overly permissive security group, right? In this maintenance security group, we have this maintenance host that is now kind of obsolete. It has not been being maintained because it's been forgotten. And it has an IAM role with quite a bit of permissions. Now, if I'm the bad guy, what I really want is over here on the right. I really want the files in this customer records S3 bucket. That's what I'm going for. So when you look at a lot of these exploits, some of them kind of classically, we've seen a lot of just a simple misconfigured S3 bucket that was public. In this scenario, I've got a well-configured S3 bucket, but an obsolete EC2 instance that has some vulnerabilities. So as the bad guy, my job is to try to find that exploit. I'm going to use, find that vulnerability rather. I'm going to use automated tools for that. I'm going to do some lookups to see what those endpoints might belong to. If I see it's a good looking organization, I'm going to go after it and then try to get to this data. So that's what we're going to do in the remainder of this demo. So switching to being a bad guy here, the first thing I'm going to do, and imagine for a moment that I have found an endpoint through scanning that, due to it not being patched, has known vulnerabilities. In this case, I'm not going to try to emulate that aspect of breaking into the Linux instance. Instead, I'm just going to SSH to it. But you can see here, 4 packages are needed for security out of 12 available. This kind of simulates an old EC2 instance that's sitting out there with vulnerabilities. And I want to point out, for the rest of this webinar, I am only going to use shell access, not root access at this EC2 instance. I don't care about getting root. All I need is shell. So one of the things I might look at first is who is this EC2 instance, right? If I've broken into this, I don't really know what this thing's job is, what it's there to do. I know there was a vulnerability I exploited. So one of the things that any good cloud hacker knows to do is to take a look at the metadata available on that instance. And a lot's been made of this in recent press, that the metadata service is somehow a problem. The metadata service is awesome. You just need to be really sure you're configuring your cloud infrastructure properly. So why do we have a metadata service for these EC2 instances? Because an EC2 instance can kind of come and go, right? We want these to be ephemeral. We want to not have to configure them and go into /etc and type a bunch of stuff into files. So things that are configuration items, we want to be able to access from that instance. So in this case, we also want, because it has an IAM role, we also want, there's a wonderful feature of IAM, which is that IAM role has rotating credentials that get populated at some frequency automatically by AWS. So you don't have to worry about secrets management or embedding those, but they are in the instance metadata. So if I take a look here at a little deeper in that instance metadata, I can go get those credentials. So I looked at the metadata service, which is running on the hypervisor, kind of upstream from that EC2 instance in the AWS hypervisor. I can look at the latest metadata, the IAM, and the security credentials for the maintenance role. Some of you might be getting nervous now. You shouldn't be really. The reason is these credentials, and yes, there's an access key and a secret access key here. These credentials only grant me permission to do the things that that IAM role has permission to do. This is not the keys to the kingdom. We need to do some other work to get to that data. But let's say I'm a bad guy. I got in here and I'm wondering, does this maintenance role, IAM role here, have access to S3? I want to see what this organization has in S3. And so I'm going to run a console command, excuse me, a command line interface command. I'm going to do a list of S3 buckets. And this should give me, wait, I got an access denied. When calling the list buckets operation, my access was denied. So I cannot get a listing of S3 buckets. So in the recent breach at Capital One, for example, we know that about 700 S3 buckets were synced according to that DOJ report. If you imagine trying to guess the name of 700 S3 buckets, you're going to have a hard time. And in order to get those names, in order to exploit that endpoint, you're going to want to do a list. And we know from that complaint that the attacker did a list. Well, in this case, our IAM role was configured well. We can't do that listing. Let's imagine for a moment that I know the name of one of the S3 buckets through other research, and I know it's called customer records. And I want to go sync everything from that customer records S3 bucket to my own personal all your base S3 bucket. I want to grab all those files and pull them down. So let's say I've even guessed or figured out the actual name of the target S3 bucket. If you remember back over here, this customer records, right, that we've got right here. Let's go ahead and try that. All right. So another access denial due to a different list call. So here, a fatal error, access denied, when calling the list objects v2 operation. So we have two denials here. One is list buckets, where I would get the names of buckets. I gave our bad guy some inside knowledge. And then when she or he tried to actually get at that, because we don't have these list permissions, that S3 configuration, that IAM connection to S3 is not going to be helpful here. In each of those buckets, usually in the real world, are many, many files, maybe thousands or tens of thousands. So getting a listing of those is extremely important. And that leads to a broader point here. What I'm trying to do as a bad guy is discover your environment. And depending on how you have things configured, that's non-trivial, particularly listing and describe calls in APIs. So you might think, well, those are read operations. Well, those are read operations, and therefore not that dangerous. Well, those are read operations that can give that attacker the topology of your system to discover things. I'll point out another thing about discovery is that the fact that this EC2 instance exists is out of date and has this old security group and IAM role that it was forgotten is itself a discovery problem on the part of the good guys. And so discovery is really, really important. It's one of the things we focus on at Fugue. What I'm showing you here is an automated diagram that shows this cloud infrastructure just by pointing our tool at that infrastructure for that discovery. But now, as a bad guy, I'm kind of stuck. But there's another thing I might try. I'm going to see if I have the ability to look around not at S3, but at IAM. So here I'm doing an AWS command. It's AWS IAM list policies. And I'm going to search through that for names that say S3. So what we're doing here is we know from before that our IAM policy is called the maintenance role. I'm going to look for other policies, other roles that might give me better access. Okay, that produced a few lines of output. It actually produces a ton of output. I just narrowed it down through some greps. And if I'm looking through here, this S3 read-write policy looks pretty attractive to me. So I now want to change the identity of the EC2 instance I'm on from being a maintenance role identified instance with its access privileges to an S3 read-write configured instance in terms of IAM policy. Let's see how to do that. The first thing I need to do is I need to go and identify how that is associated, how the IAM role is associated to this particular EC2 instance. And I have the ability to do that through an EC2 call, AWS EC2, describe IAM instance profile associations. That association gives me that mapping, and I'm going to need that to try to hijack this other role. And here we go. So I now have the association ID that I can use to change this role. Let's jump back over to the console for a second and take a look at this S3 instance, excuse me, this EC2 instance. And you'll see here that it was started life with the maintenance role right here. That role was intended for that maintenance function, but because I had two liberal permissions for IAM and EC2, because when I was standing this up at 1 in the morning, I didn't have the exact map for least permissions to do exactly the tasks I needed, so I made it overbroad. And then because we didn't have excellent discovery of infrastructure, it sat out there too long. This EC2 instance is actually capable of changing its identity. What that means, you can think of IAM and identity in cloud as kind of like another network. So when you're defining access in the traditional kind of data center computing world, you're really thinking about like IP address blocks and ports and protocols. But this EC2 instance is communicating with things like these S3 buckets. Of course, behind the scenes, there's IP, but it's not really visible to you as a consumer of cloud. What's visible to you are the permissions granted through identity, including the ability to do things like list. And so you can think of this more like an overlay network. And I think people really haven't fully grokked how profound this way of interacting with cloud infrastructure is, both in terms of its amazing power and capabilities, and if configured well, how secure it is, but also what are the vulnerabilities? What are the things that a clever bad guy is going to exploit? So we'll go a little further. And I'm copying and pasting these commands because they're pretty long, and I tend to fat finger things when I'm kind of live on the air. So I'm going to replace this association ID. My editor is off screen here, getting this command set up. Okay, so this is a kind of verbose command, but it is AWS EC2 replace IAM instance profile association. You may not have used this at the command line, but you've probably seen it at the console, I'm just going to show you where this lives. So I've selected this host, and when I say actions, instance settings, attach replace IAM role, that's what I'm doing at the command line. This would be the console way to do this. So let's see if that works. And I saw that S3 read write policy that looked pretty enticing to me. So I'm going to go ahead and try to replace my association, my mapping from this EC2 instance from the maintenance role to the S3 read write role. And that is the look of victory. So I now have this instance ID that I'm on. And by the way, if you have these permissions, it's possible, depending on configurations, to do this to other things as well. So another thing I might have done here, if I really wanted to hide my tracks, is spin up another EC2 instance, a really small one, and spin it up with this role. But in this case, I'm showing you how I'm doing this by changing out the role in real time. So I've now gone to the S3 read-write policy mapped to that role. So let's take a look again at my metadata. And I'm going to go ahead and look into IAM. And security credentials. And hopefully I didn't put a typo in there. And now you see I have this S3 read write where before I had the management role. So that was successful. I now have S3 read write. I can similarly try to go ahead and get the details of those credentials in terms of the actual credentials to log in. And here they are. So I've now laterally moved from that maintenance role to an S3 role. Let's get back to trying to do some discovery on what's in S3. So the first thing I'm going to do, not S3 or S2 or S4, it's S3. I'm going to do a listing. Now I get a list of those buckets. So now I can start to do discovery. And similarly, if so I've got this customer records bucket. Remember, this is what I'm looking for. So I want to go back to the console. And let's go and look in S3 at what's in that bucket. So in this case, it's just some vacation photos I took when I was driving around Iceland. But in the real world, this might be a lot of customer data. It might be tens of thousands of objects. But I want to point something out here, which is to guess file names like these is extraordinarily unlikely. I mean, these ones are, image files, so they have probably not that hard to guess. But if you're doing a programmatic approach to populating that S3 bucket, the ability, even when I've listed buckets, the ability to know what to target in those buckets for a command like sync, which we know from the DOJ complaint was used in the attacker recently. I need list of both things for sync to work. We saw that error before. So let's try that sync command again. Well, now it's happy. So what I just did is I created an S3 bucket called all your base. This is where I want to steal your data to. I've targeted S3 customer records, and using the really handy sync command, it got a listing of those things and iterated through all those files and moved them to my all your base S3 bucket. Now this one is in the same account. This could be an external account. So if I were really a bad guy, I would have created some public S3 buckets and routed those there. There's an important aspect to this to note. If you're thinking, well, I should be catching this in my SIM. This S3 bucket is not inside of this VPC with its flow logs, etc. And that S3 sync command is not going to produce an unexpected burst of TCP IP level network traffic for security to throw an alarm on. Those are the kinds of things we're trying to look for in security. But in this case, these are all API calls, and the network interactions are largely happening behind the scenes. And I believe this is why these kinds of attacks often go unnoticed for a very long time. You might say, well, wait, what about things like CloudTrail? What about the logs of the API interactions? Well, the API calls that are being made in order to do this look a whole lot like normal use of S3 objects. They're read commands. So the broader point here is you're unlikely to know that this has happened when it's happened. You're unlikely to find it after the fact without some other evidence coming forward. And therefore, getting configuration right up front and monitoring configuration is particularly important. So let's jump over here and take a look at, and this is the Fugue console, but I want to see actually what those configurations might have looked like had I been trying to catch them ahead of time, those misconfigurations. Let's scroll down and look at failures by rule. Actually, let's look at failures compliance by resource type. Let's look at security groups. And here we'll see we have a security group that is configured that breaks a rule. Similarly, Fugue will do what we call drift detection, which is the ability to establish a baseline. And then once that baseline is established, the baseline being the captured known good configuration of cloud infrastructure, once that baseline is established, we can then detect drift. And in this case, we would have gotten a drift notification that the IAM association of that EC2 instance had changed to one that created vulnerability in our infrastructure. So now if I'm the bad guy, I'm going to get out of here, right? I've only been in here for a few minutes. This is not rocket science if you really know how to try to probe and exploit these kinds of misconfigurations. So I would, at that point, leave and probably leave you in a bit of a lurch. Another point to make on things like security groups, S3 configurations, and so on, we firmly believe that because the bad guys are automated, you also need to be automated on making sure your infrastructure is to a known good baseline, is in compliance. So I'm going to show you just I'm going to describe a capability called self-healing that allows you to automatically reconfigure cloud infrastructure back to that known good baseline. For some reason, I'm not able to show it right now. Probably user error on my part. I apologize for that. But using Fugue in a baseline, you can actually not just get a drift notification when something changes, but instead also have Fugue automatically remediate it without writing any code. So that's what I had to demonstrate today. A little review on what we did. The first issue was the firewall misconfiguration. And that security group misconfiguration really should be caught by your monitoring tools and by your remediation tools. But in this case, it wasn't. Causes of misconfiguration often include drift and orphan resources. It is very common to see 20, 30% of cloud resources in a given customer environment kind of questionable as to where they came from, if they're still in use, etc. Step two was I had an old EC2 instance with a known vulnerability that I exploited to get shell access. And these often go together, right? If you're aware and maintaining infrastructure effectively, then you know about the things that are in your CMDB. You know to keep them patched and updated. But if something's an orphan resource, you're probably not paying attention to it. So step 3 was I had to get from not having access to S3 to getting access to S3. And so I leveraged IAM's ability to change my actual permissions and therefore my view of the cloud infrastructure in order to go after my target, which was the data in that S3 bucket. And that allowed me to do bucket discovery and duplication. So a few recommendations, and we should have about 15 minutes left at the end for Q&A. A few recommendations, well, key takeaways and recommendations. Monitor all your access point configurations. You should always know your access point configurations all the time within minutes of change. And the reason for this, I'll go back to when I was talking at the beginning, the bad guys are looking for these 24/7 with automated tools. Minutes is really how quickly you have to not get hit by one of these attacks if somebody notices you, and they're probably noticing you. It's whether they're prioritizing you. So hours, days, manual work on this is just not fast enough. Step 2 is kind of obvious and you know, apply principle of least permission. Ruthlessly limit IAM roles. Yes, but when I get called at 1 a.m. to get the application up and running again, I may not have an IAM role handy that gives me the permissions. So what does that mean? In other words, this might be a legitimate user error that is understandable given the business constraints that we're operating under. So I think that the way to handle this, I mean, to some degree, it is just a complex problem. But the way to handle this is to give those individuals feedback in real time as to how dangerous those IAM roles and policies are. We spend a lot of time on that at Fugue. There are a lot of hidden gotchas in that. That's one part. Another part, though, is if you think of IAM as like a network, you need to invest in IAM security the same way you have invested in network security. Right? It is at least as complex. And a lot of tools aren't available yet. There are some pretty good ones. We try our best, certainly. We think we do a pretty good job. But the important thing is that you as an organization, if you want to prevent cloud misconfiguration vulnerabilities and therefore effective attacks, you really have to have an engineering focus on not just your network, but also your IAM as well as your overall configuration. One thing to think about is use different endpoints for read and write. Personally, this says eliminate S3 bucket listing in production environments. I would argue that almost in your production environment, in those VPCs and subnets, public subnets and even private subnets, because people can jump around if they can find an exploit and get in, that having listing capabilities from those places is dangerous. And there are better ways to do it. So if your application is writing a lot of objects into S3, and those are part of a database transaction where you know those IDs, maybe query those IDs from the database rather than leveraging the listing API for S3, or for that matter, listing things like IAM or lots of describe calls. Discovery is what the bad guys are going to do first. And so what's convenient for you is convenient for them. And then don't allow EC2 instances that allow attaching or replacing role policies in those production environments at all. That should be a red flag. If you have something out there in production that has those capabilities, that is access to a completely different view for discovery and new capabilities to exploit anything that is discovered. Clean up your unused cloud resources. Especially EC2 instances and S3 buckets. Orphaned resources are really common, and they're dangerous for two reasons. One, you're probably not looking after them properly, and two, they create attack surface. The way you need to do that is to use discovery tooling to really understand what's going on in your environment. we do this with multiple vendors for our own products and our own use. Include cloud misconfiguration in your pen testing. Get pen testers who can do what I just did, who know how to do that, and really point them at that infrastructure to try to find these vulnerabilities before the bad guys do, because the bad guys are clever, and they are leveraging every capability of cloud and cloud APIs to try to find ways to wiggle through and get to data. And then finally, here, use automated remediation for security critical cloud resources. You really need your VPCs, S3 buckets, security groups, EC2 configs to some degree, and IAM roles to be tightly managed, minimally drift detection, not just log filtering. Drift detection, again, with Fugue, for example, would have thrown an alert, hey, somebody changed the IAM role association. But in the best case scenario, use automated remediation. Have that tool, like Fugue, automatically fix things back to the known good state rather than cutting a ticket and getting a human to spend their time filtering through all the tickets, finding the right one, and trying to close it. So with that, we'll have some Q&A. Why don't I turn it back over to Drew for finding some questions for me.
Thanks, Josh. And yeah, please do send any questions our way in that Q&A tool in Zoom. So we got a couple that I think are kind of related around IAM, and I think something that you said, Josh, around how, you know, IAM is more than you know, what it might seem on the surface. So trying to just kind of compile some of these questions. Can you just talk a little bit about how IAM kind of changes the landscape a bit in cloud with regard to security?
Sure. So think about the kind of old world, the pre-cloud world, the data center world, where connectivity between components of infrastructure, different servers or servers in different appliances, was largely configured via TCP IP addresses and ports and protocols, right? So you would have network configurations that your application servers could only talk to your web servers based on their IP address space, and you would have devices in between looking for that. You would also be doing things like intrusion detection and packet capture at that network layer. So we've got years now, decades, of understanding how to think about the network as this configurable dynamic entity that people are trying to exploit. Well, when you think about IAM in the cloud era, there are some intersections with IP networking, but not as many as it's inadequate. So in IAM, you are granting permissions to do API calls against particular kind of chunks of infrastructure via the roles of those entities. And so you can think of this as another network that doesn't show packets. And you have to analyze it that way in terms of leveraging IAM capabilities, identity. And people have talked about this as being kind of like a identity escalation. It is, but it's different than going from the Josh user account to the Drew admin account on a Linux box. In this environment, we're talking about the interactions across the whole cloud infrastructure that's in constant motion. So in addition to that, you saw the amount of power that IAM offers, which also means the amount of complexity that it bears. And by the way, I'm a big fan of giving developers power and therefore having complexity, right? Unixes have taken largely over the world. They grant the users a lot of control, a lot of power. I'm not advocating that people choke down folks' ability to do powerful things using these really cool cloud tools like IAM. But you do need the ability to know if what you're doing is dangerous or not. And I think that's where a lot of folks get in some trouble.
Okay, next. Were the configurations that produced those access denied messages to you when you were trying to list resources, were those on purpose, or were those default configurations?
Well, let's go into the AWS console real quick, and I'll show you what I did. So I'm going to just make a new IAM policy here. Let's go to policies. I'll create one. And so the first thing I'm going to do here is I'm going to choose a service that I want this policy to work against. And in this case, we're talking about S3. And you'll see here there are a number of groups of permissions here. So you've got your write permissions, which include, deleting objects, deleting buckets. Obviously, this stuff's pretty dangerous. This is, management level stuff. You don't usually want this out in production. You also have read permissions, getting objects, getting bucket ACLs, and you can select these individually, right? So kind of the happy path here for read would just be to select that gets you all of them. You see some lists in here, like lists of jobs, bucket versions, by tags, if you know tags, but the list commands here are the ones that I did not turn on in that policy, just because I didn't check this, right? So AWS does a pretty good job of giving you a fairly easy path to getting reasonably good configuration of an S3 policy. I would also argue that you might want separate policies that are assigned to separate compute resources for read and write operations, and you probably don't need all of these read or write operations, but getting rid of list is not super hard.
Okay. Are there any specific types of companies or cloud environments that are more prone to these kinds of misconfiguration attacks?
Boy.
And I'd add too, there's another question that, what in your opinion or from your experience is kind of the prevalence of these kinds of misconfigurations that you showed?
Yeah, so every time, both when I was at AWS and here at Fugue, that I've looked at an AWS account that's being used at scale, there are misconfigurations. One of the nice things about Fugue is we can sit down for a half an hour, point it at it, and show you a lot of those misconfigurations. And, I hope somebody listening here does this free half-hour workshop we're offering and is the first person ever to not have any misconfigurations. But when you're operating at scale, it is extraordinarily likely that some of these are out there. And in fact, I would say that you need to accept the notion that they're going to happen from time to time. In fact, they're probably going to happen frequently. And so your job is to find them and remediate them as quickly as possible because it's a fact of life going forward on cloud. So I hesitate to say 100%, but I've never seen a cloud environment at any kind of reasonable scale that didn't have some configuration vulnerabilities. As far as who's a target, let's go back to pretending to be that bad guy who is either purchasing or themselves running, scans of environments and so on. I'm probably going to get a lot of hits. And so I'm going to go back when I get those hits, when I find those misconfigurations, and try to pick out those cloud accounts that look like good targets. And I think we've seen that in the news with the kinds of organizations where the bad guys actually say, hey, I found a vulnerability in this large Fortune 500 or this big international bank. I'm going to go for their data. But you're not safe if you're not one of those folks. If you're vulnerable, you're vulnerable.
Got it. So a single bad misconfiguration can put a target on your back. Okay. Why would you say using CloudTrail log monitoring is insufficient here? Because it did see that.
Well, it saw it amongst a bazillion other API calls usually that are going on in that infrastructure environment. And I would argue that you might be looking for IAM associations calls in CloudTrail. You might not. Most people I know aren't. That's something to do. That's after the fact. CloudTrail trails usually 15 minutes to up to hours is one problem. But on those S3 operations, there are API calls in there, but they're S3 read operations. So the problem with doing scouring logs for this kind of issue is, one, it's after the fact, right? You would have learned your data got stolen sooner, but that's not a great place to be. And two, it's really hard to pull out the signal from noise. It's not even, with those S3 calls, it's not even really looking for a needle in a haystack. It's looking for a 2-inch long, slightly darker piece of hay in the haystack. So I've never seen that used to good effect for all of these kinds of things, and it's after the fact.
Got it. Okay, great. Next one up, is it possible for an attacker to do the reverse of discovering the S3 bucket from an EC2 server? So with the access to the bucket, find its corresponding EC2 server?
Never tried it. Won't say it's impossible because I've never tried it, but nothing is coming to mind how that might be done. I'm not saying it's not possible, but I've just never given it a shot. But now I know what I'm going to hack around on this evening. So thank you.
Great. So hackers want to discover what's in our environment. How can we go about discovering what's in our environment to protect it?
Yeah, well, there's a number of ways. You know, I don't want to make this all about Fugue, but we do that. We can do that in a few minutes, usually less than 30 minutes for you. There are other ways too. You can go and, using APIs on cloud, pull down a lot of configuration data about, you know, describing all of your EC2 instances and so on. I think that for me, I'm a pretty visual person, and so I find this ability to just visualize the infrastructure and see change over time to be a really compelling way to do that discovery, rather than having to fish through tons of you know, log data or other kind of tabular data. So this is our visualizer again that can show you some of these. And by the way, the stuff that's painted red has policy violations that we can tell you about. So obviously we've spent a long time on this. You don't have to use Fugue to do that. You can use other methods, but it's just really important that you do it somehow.
Great. Do you have any specific recommendations on how to get started on improving our IAM usage?
Yeah, definitely. Go through and look at all your policies. Look for list operations. Look for any stars against any service types. Look for the pieces of EC2 and IAM permissions that allow for role assumption. I mean, we know from the tweets from the hacker that got busted recently that she was doing role assumptions. So there are a number of things you can look for in those policies. We do a bunch of that stuff, but you can do it yourself too, just by pulling down those policies and looking through them. That's easier said than done, by the way, but it's worth doing, right? Whether you use our tool, which can help you with that, or you do it yourself, there's a lot of risk there.
Okay, we've got one more in the queue. If anybody wants to ask, this is your last call to ask a question. We use a multitude of provisioning tools. You name it, we use it. Can your product help us not make it into the news?
Well, thank you. Yes, we can. We don't care what provisioning tool you're using, whether it's Terraform or CloudFormation or Ansible or the console. We can do discovery. We can do policy comparisons, right? What I just showed here were based on, I think, NIST and SOC 2, et cetera. And we can do self-healing infrastructure no matter how you've provisioned, no matter what tool you're using. So we're provision tool agnostic. Okay. Well, again, reach out to us, fugue.co/workshop. We can show you what we do. Also, if you want to reach out to me, I'm josh@fugue.co. If you have any other questions that you think of later, fire them over to me, and I'm happy to answer them. And really appreciate everyone taking the time today. Drew?
Thanks, Josh. And thanks everybody for taking the time. We will reach out to you with a recording of this webinar.